everyone, we are also continuing with the workshop. For everyone who's like participating and live coding, please move a bit to the front so you have the full attention. Sag mal. Jetzt?
Das ist ein Sag mal was? Das ist hier.
Also.
Dammit. Hast du den Link irgendwo hier drin, dass wir das machen können? Sag mal was. Hä? Jetzt komplett.
Test. Perfekt. Ja. Nice. Okay, does it work? Okay, nice. So welcome back. I see we lost a couple of people, but those of you who are here, we can continue exactly at the point where we left off. So let me keep this going. Okay, nice. All right, so where we've come just before is to see that we could deploy the Anchor program, and now we can also see it in our front end. So if we just go to the link, we should see our own Anchor program that we've deployed, and you can see all those parameters that you would see in a regular contract, but now let's interact with it finally. So in our smart contract here, we see there is an initialize function. Let me make it bigger. And this is a function we want to create. Basically, what it does is it creates another account for us where we can increment a counter. So we can count up or down whenever we like to, and it's directly accessing the blockchain on the DevNet. So let's do that. And from now on, every single transaction will be done through the wallet. I first have to unlock my wallet and approve that I really want to interact with the blockchain itself. Just make it bigger for you. It takes some time, and now we see there is a validation. We could create our own smart or another account in this smart contract. So there's the hash. We see the result is successfully done. And there we have some parameters. For example, we see that this wallet that I have, starting with Mike, just lost a couple of Solana. These were just the transaction fees that we had to do on the smart contract or on the blockchain. So we have here, we see there is the fee payer, which in this case, I am the signer, and we created a new one. So we can also check it here. There is a link to this specific address inside our smart contract. And we can also check this one out, which is just a subcontract created by the main one. If we look through the main contract, it should also be a transaction written inside here. So we saw before, 2 hours ago, we've created the smart contract, and now we have a new sub-account for this meta. And just for the sake of demonstration, we can create a new one. You can also do it locally on your machine. And since this is already on a DevNet, it's public, but not on a mainnet. But technically, if you would like to share your address with me, I can also look it up and see everything that you see on your screen. So technically here we saw there is a new smart contract creator or a new account in this contract. I could share you the link and you would see the same thing. So it's already sort of live, but it's not the mainnet. So it's just for testing, right? And here we see there is a new contract. If we go back to the main contract, which is the top level contract, let me delete the other ones. Then we should see 3 transactions exactly. First one was the initialized one. Then there was one for creating a new one, and then another one. So in total, we have 1 smart contract with 2 holding accounts, and we can interact with it through the front end. And this is possible because we are not like reading the blockchain directly in the sense as we get all the information will be displayed anyway on chain or like in our interface, but we have to interact with the IDL. Now the IDL is like a JSON file, which we can find in our Anchor file. There is under targets IDL, which it's basically the code interface between Rust and the front end, so we know how to interact with our contract. Now there are some defined metrics that are readable for like regular web stuff. So the way we interact with the code is not directly through reading the Rust file itself, but we need this IDL. Now, fortunately for us, since we use Anchor, it will create one for us, and inside this boilerplate that we have, the scaffold that we installed, we can directly integrate it. And this counter one is already implemented in this front end, but obviously we can change it either way. So if we have another contract, we would just have to apply the parameters. Now, let me ask the audience, did you try deploying a sub account yourself? Did it work for you? Did you try, or like, have you gotten to the point? Yes, exactly. If you press the create and sign the contract. Maybe we'll have to relaunch it. So if you go back to the terminal and run npm run dev, maybe that would fix it. Again, just closing and opening. Usually that should be fine because we didn't change anything else there. So if along the way you could create your own smart contract and update it in the front end, then you should be able to interact with it directly. Yes? I see. So there, the problem was there's a mismatch with the declare ID. It seems like you're trying to read a contract that is not created or like an older one. So either when you have here the declare ID, it might be that you didn't overwrite the previous IDs to use it in your front end. So there might be some issues with that. So make sure to, if you have this older address, if you can search for it, it might be that at some point in your code it's still there. So it still looks for the old contract, even though you have declared a new one. So make sure to really have the new address overwritten on all your code spaces with the new updated contract, because this is the one that we want to interact with. So we want to change every place in the codes with the new contract. And maybe if it still occurs and you don't know where the problem is, then what you might look into, I can also display it here for the purpose. 5 places where we should have the address changed. And if you are stuck somewhere where you are not sure what happened, I suggest you to create a new key pair. So again, overwrite the current one, and then look for those files. So here in the anchor.toml file, it should be updated with your new address, or like the new account. Then the lib one, I mean the smart contract, which is the first one that we changed, would also be updated. And yeah, then again, here in the name minus export.ts, which exports the public key to the front end. Then again, with the JSON, this will be the IDL for interacting with the smart contract itself. And also the name that you've created .ts, which is basically also just the IDL. So both of those things are the IDL, as far as I can see. Has the exact same files. Yeah, and this will be created automatically when you run Anchor builds. You just have to change the address. So once this is done, you should be able to see the new contract and then interact with it just as I did. And the nice thing with Solana is that if we create accounts, we have to pay some rent for it. So like some fee, some Solana that we pay for the infrastructure to hold the data. But the nice thing is, unlike with Ethereum, for example, we can also close the accounts. So all the rent that we've paid for, let's say, this account, we can close it, sign a transaction, and it can only be done by the creator. And then get the money back from the contract creation. All right, great. So now it's gone, and it's literally erased from the blockchain. So it's not like really permanent storage as it would be with other blockchains. This is a thing that you might think about when you are deploying something or interacting with Solana. Now, what can we do with this smart contract? Since it's like a very simple contract where you have one number, you can either increment it, decrement, so and set the number. In this case, I could just increment, which is like a simple function to count up by 1. And so, like with every blockchain interaction, we have to sign it with our wallet. There was the transaction hash, and the state of the blockchain was changed. So now, instead of 0, we have 1. I can also change it to like 10 immediately. So this is like very simple smart contract interaction. Did anybody of you got to this part where you can create your new own contract? Nice. Did it work? All right. Is it happening on the front-end side? But you could create the smart contract, and can you see it on the Explorer? So if you type the contract address itself in the Explorer, you can see that it was successfully deployed. It should be similar as right now on the screen. This is like, okay, so this you can see. Okay, nice. So it seems, all right, so maybe really it probably is like some error with these files, that at some points it's not really written with the current address probably, or we can also look into it later if you like. But yes, exactly. So this is how we would create sub-accounts. And this is like just very simple stuff that you can do with the boilerplate that's provided. Now, what might also be interesting for you is to how to get access. So for example, we have this account that we have. And since you created now some contracts, you are working with the blockchain, and now you should also see some transaction here. And this is basically what's done in the background. There are API calls that use this one thing that we had here. Let's see in the config files, the Solana config get files, we see there is the RPC URL. And later on, if you would implement some features where you want to use like more sophisticated API URLs, RPC URLs, where you are looking for speed and want like your private access to it without restrictions, then you might need to have your own RPC providers. This is also very usual for Ethereum-based projects. So let's say you might go to Alchemy, which is one RPC URL provider where you can get your own access with a private key or with an API key that only you can access and get like more throughput. Now, if you would create like one of those RPC URLs, you can change it in the config files. This is just as same as we did it with the testnet, but since it's not predefined, you would need the config set URL, and then instead of devnet, it might be the Alchemy with the key and everything there. So this would be like for further development. But we don't need to get too much into detail for now, and for basic testing, the one that we have, the public one, API devnet.solana, is sufficient enough. Aside from all the blockchain programming now, I would also like to show you how you can take this website yourself and deploy it so other people can visit it. Now, this is specifically for hackathons. If you want to show somehow what you've done, they won't be able to just access this URL, this localhost 3001, because it's just on my machine. Now, since we have created it with Node, with Next.js, which is from the company Verso, we can go on the Verso website and deploy it there actually. The thing is that at first we should need some repository somewhere to upload the code to. Now I saw that most of you use GitHub, and this is what we also will be using for this purpose. So head over to GitHub, create a new repository name. In my case, it will be superteam101. Just the same name as I created the code before. We can keep it private. It doesn't have to be up to the open. We just have to have a place where we can give Vercel access to. So in my case, I will keep it private just to be safe. And then we will see there's already some commands that we can use to upload it. And I will just exactly use that because you don't need really a lot of experience with Git. But I've seen that you've worked with that before, so that shouldn't be a problem. I will just direct to my base directory, which is Solana 101, and create this README file first, initialize, as in with every Git repository, we have to initialize it. Just to make sure that we have everything there, I will add the entire directory with git add and then a dot. And let's make our first commit. So with every push that you do, we have to leave a message. This can be first commit, why not? So we have defined a repository where we want to deploy it to. At first, we created a Git repository in general. We've added all of our code that we've created. We committed, so we have the message with all the codes like bundled together. And now we specify the branch, which is like the specific directory within your Git codes where you want to deploy it, which will be the main one. Main is always the first one that we use. And then we need to add the origin, which in my case will be my GitHub handle and then the name that I've created. Let's do that. We add now the link from the code to GitHub itself. And then the only thing we need to do is to push the entire code. Great, seems to have worked. And all the code that I've done is already deployed here. Now what we can also look into is that we have or should have a gitignore file. This is a file that specifies what things should not be deployed on GitHub because we don't want our private keys deployed there, right? So this is where, for instance, environment data is stored, and there should be some build. So build is technically the thing where we created here in the target file. Is it the build? And it should be deployed, right? So let's just check if we have on our anchor file the target and then the deploy file should not be there, because otherwise, if I would have this code online, people would see my private key. So let's see, we are in the anchor file, and then we should see the target file. There is a target file, and inside the target file, there is only the IDL and types. So as we can see, the deploy file where we have specified our private key is omitted. So we won't leak any private information or like keys that other people might use to tamper with our product, which is needed because we don't want people to just use our smart contract and do whatever they like with it. Now, this deployment went pretty fast, and I can also show you how fast it is with Verso. So if you haven't created before, you would first have to go through regular login, and then you should just add a new repository. Let me see where it is. So I go to my projects and add a new project. You saw there was already one project created, but I want to, because I have set the permissions in a way that I don't want Verso to look through all my code. So I want to specify exactly which directly they should target. Now, which means that I have to give new permissions. So I go to my personal GitHub again. I have to do some verification process there. And set the repositories that I want to add. So the one that I want to add in this case, or like give Verso the rights to use my code, would be Super Team 101. And now I would have 3 new projects that get access to, or like that Verso gets access to. Now there's this new one I just created. Let's import it. And I want to, now here you can specify the name and what the URL should be in a future case. So let's just leave it as Super Team 101. It's a Next.js framework. And you can see you can also use other ones. So if you stick to React, you could technically use React as well. But since we use Next.js, we do that. The root directory might be necessary if we have like a more nested directory. For example, if we have first the super team, then there is another directory you would have to specify. First go into the next directory and then deploy it, because we cannot just run code wherever like. So if you are here at the super team and I do npm run dev, then it won't run any code because I would have to be in that exact directory for it to work. But here it's a base directory, so we don't have to change anything. And I don't specify anything else. We don't have environment variables. This might be something like the API key. If you would specify it where the code should first look at the server, then calculate it and send it forward. So let's deploy it, see what happens there. Have you ever deployed something on Verso before, or any online projects? All right, so some of you might be familiar with this. But this is basically like a walkthrough how you could do it later on in your startup or the hackathon itself. So it's still deploying. And basically what happens in the background is whenever you want to deploy your code and check if it would build on a higher level, then what you can do is this npm run build command. Let me make it bigger. All right. This npm run build command will check for any dependency issues or build issues. I just recommend you to do it before deploying on Verso, because then you'll see if your code actually compiles and will be looking just exactly as you saw it on your local machine. So in my case, there was no problem whatsoever, which is great. So coming back to Verso, we should see the deployment finalize in a bit. Usually it runs for a couple of minutes. But yeah, now we saw that there are some build logs. And okay, the website was created successfully. So we see there is the exact same thing that we saw before. But now if you would head over to this website, you can look at yourself on superteam101.verso.app. So it's online already. You can just go directly there, interact with the smart contract I have created. But again, since this is another workflow, another place where we would interact with, we would have to assign new rights. So we have to log in again, approve our wallet, and then we would get access. Now, how it differs from the code that I have here on my local host is basically that you can access this code, but not this code. So this is like just a live version of what we have done. And a cool thing about Versal actually is that, let's say I want to make some changes to the front end. Let's say here we are on our local net or local host. Go to the main page. All right, it broke down. So let's just start again. That happens quite often actually. Restart it. This might happen after you build the code. Just restart it and then it will work again. So let's see where this code is written. And whenever you have like new repositories and you don't know where code is, the easiest way to do is copy the couple of words that are on the screen and search for it. This is how I've also done it. And we see it's in a dashboard feature. Now, if you would like to know how it's done, we have, let's close this anchor file. We have this source file, which is for the front end. And yeah, there are the dashboard features. So let's say instead of GM, we want to say GM Super Team Germany. Now we see it locally. However, we don't see it on our chain here. Oh, I see somebody also created or interacted with this contract. Was it one of you guys or from the online? Okay, nice. Yeah, so now you can see how it works. Somebody else can interact with my DevNet code. Very nice to see. But yeah, here we have the older version. So it's just a GM version. Here we have GM Super Team Germany. Now, another thing about the development with Versal is that we can have this entire workflow in VS Code or Cursor or other IDEs streamlined. So we can either do it through code, the whole committing and pushing, but in this case I have an extension that lets me interact with it more easily. So I have done some changes, and then I have to commit it with some comment. So I'd say change to GM Super Team, just for the logs in the Git, so people know if I interact with somebody else what I've done actually. So let's do that, sync the changes, and in the background what happens is it will forward the code to Git. Let's check that. Oh yeah, there are some workflows. Actually, those workflows do not work, so I won't go into that. You can just delete them. Those are some test metrics. But what's necessary for us, or what's interesting for us, is to look into the deployment of Versal. So let's go to the dashboard. And we see there is an active change because we have submitted it to the main branch. So the main branch is, if you go to GitHub, we have only one branch and we only work on this currently. So what Versal is doing, it looks for the latest updates on GitHub. And if there are some changes made, it will open up a new task and redeploy your code. After a while, we see the task isn't there anymore. So something was changed, and now we can see online, if I reload, that the changes were actually done. So this is like one of the fastest experience I have personally done in the development process. I've used like a React before, and then with other third parties, how to integrate it with code. But with Versal, and if you want to really spin up a quick project on Solana, it's the fastest way on how to do it. And yeah, let's maybe just go into like some other aspects of what you can do in GitHub. Because basically, if you have like bigger projects and you want to scale in a different way, you would probably have other collaborators as well. So maybe the best case wouldn't be to only work on the main branch. So for this part, we should create a new one. So let's create one that's called Dev. The source will be what branch we copy. And let's just create one named dev. If we go back to the code, we should see a main branch and a dev branch. Now both branches are the same since I just copied from the main to the dev. But let's see how it works through our IDE. So regular git commands, let's say I want to know my branch, not bench. So we see I'm in a branch git repository now. I have to check out git checkout and then was dev, right? Git. Okay, git branch dev. Then let's see what the git branches are. Yeah, I've just checked if there is a git branch. It was created to my repositories. Now I have two branches. Firstly, the main branch where I'm currently on. So you can always see with the asterisk on which branch you are. But in this case, we want to change to the dev branch because we want to make some changes that might be potentially risky. So let's check out to the dev branch. To verify if I'm really on this branch, we can check again on the git branch. And now we see I have changed to the dev branch. Now, the positive aspect about this is that if I would make some changes, let's say I would make some critical stuff that would break down the code as like a simple apostrophe, which the web cannot handle for some reason. Let's check if it really broke down. npm run build. This is how I recommend you to test your builds before deploying. It will be just a faster way instead of waiting for Vercel to compile it. And we see it broke down. It's had an error. It cannot handle any asterisks. So it would break down in the build process. However, this might, you can only see it when you actually run the build program, because if you look it up in your local host, it looks pretty fine, right? So just one thing that you should think about, if I would deploy it then on the devnet or on GitHub in that case, let's say deploy with error, and you would publish the branch. We see there was some push made to dev 7 seconds ago. And the interesting thing about this is you only work on the dev branch, you don't change anything on the main branch. So the main branch is still the same, but the dev branch now is running through. And on the Vercel side, we are trying to deploy it as well. Now, there was something, probably already saw that. Let's see. Yeah, there is some workflows. Vercel itself says the deployment has failed. And if you would have done it on the main branch, what you would see is that the website that you've created would break down and you wouldn't be able to see it. So this is like a part where you work with other devs and they didn't do the build command or made something wrong. You can still see it's not on the main branch, it's not in production. You can still change something before deploying it finally. Now let's fix it here to demonstrate how the workflow might look like if you would make it correctly. So I fixed that. Just check again if the build works this time without the error that I've put in. And maybe so we can see I changed this here as well to one with 3 exclamation marks, just to see that actual changes were made. So fixed bug. I committed. It will be only updated to the dev branch. Now, for those of you who haven't worked with different branches before, let me show you also how to combine things, because you will not always want to be on a dev branch, but sometimes put it at some point to the live website. So this is what we will be doing as well. we see there are some changes. GitHub is already proposing us to do a pull request, which in this case would take the dev branch and overwrite code on the mainnet. So let's make the title. I will keep it dev. It doesn't matter that much right now. And here in the background, we see like there are some comments. The first deployment didn't reach. It was 2 minutes ago. Right now, the commit. Okay, it's worked out. So Versal, before combining, already tells us everything went fine. You can deploy it. It will compile and show you the newest version, which is nice. So let's create this request. There will be some other changes, some other fixes or checks made. For instance, are there like some critical errors, like the main branch has something that's completely different, or there are just code conflicts. If you would combine it, it would break down. But in our case, we did some small changes, some easy stuff, and then there are no conflicts. So we can just merge the pull request, verify it, everything looks great. And now the merging starts. Merging itself is also like a push request. So just like pushing to the dev branch, right now we push to the main branch. And here we also are waiting for Versal to deploy the code. This always will take a couple of minutes until it's done. But at the end, this is also the local net that broke down. But at the end, we will wait until our official website has some changes. So we can wait for that, see on Versal itself, it's still deploying. Now it's done. So let's see if the changes are updated. And we see now on the website, you can see the one with 3 exclamation marks and no error because we fixed it. So yeah, that's basically it. I see some of you created some other sub-accounts to test it. You can also do it yourself. It's Versal is free of charge, so if you are on a budget and like to deploy something, you want to show your jury, definitely Versal is a nice application, a nice interface that you can use for your deployment. Do you have any questions so far, or something about the whole process? Maybe something I explained too fast, or that you would like to see again? Okay, the question was how to change to the DevNet in the Backpack wallet. So we have this account. Then you would have to go to settings and then to preferences. Then you would have to activate this developer mode. But after that, if you have done this, you still have to go, probably you wouldn't see this DevNet here. So next to your imported wallet, there should be a Solana icon. If you click there, you would have to add the network. Then scroll down, there will be this Solana DevNet, and there you would have to add it. Did you get it, or should I go through again?
Yeah, I think I found the DevNet.
Mm-hmm. Okay, nice. So can you see your own wallet now with the DevNet? Nice, nice. Any other questions regarding the things that we talked about earlier, or maybe the Versal deployment? Okay.
Someone asked in the chat if we will study escrow.
Well, at least I am not going into that. You mean like escrow contracts as of the Ethereum base? I'm not going into that. No, this maybe the other workshops later might go into it. Not sure. Okay, then we won't go into that today. Any other questions or something you would like to know? Maybe if you'd like to know how to generate your own private wallet with the prefix, I can also show it to you. It's just like a fun trick. You would like to see? Sure. All right, so this is the thing that I mentioned today in the morning, that you can use the Solana CLI to generate your own wallets with like a specific prefix. So you actually mine for your wallet. Usually your address might look like this here, the ones that we have in Anchor, source, lib here, like a very random characters following by another. If you would like to have it differently, like I have done it, Solana address, like I here have Mike as prefix, which was already hard to mine. It used several millions of wallets that it would have to go through. But I can show you the command that you would need to make this happen. So it's still Solana keygen. And then you would have a suffix of starts with. And then let's say we don't want it to search for too long. Let's make it with a pay prefix, which is fairly simple. This would be the command for you. You can also change it either way. There's nearly every character. There are only exceptions, like you cannot have an L or an I because those characters seem similar. So it's still like base 58. So there are like some restrictions, but there's still like lots of things that you can do. So let's say I want Michael, why not? It shows me an error. It cannot start, or like there is a problem. It does not show me what the problem is, but basically there is an L in it. So if I just have the L, it also does not work. Just keep that in mind. But pay has the characters that we can use or not. Right, so it's probably I've wrote something wrong. Solana keygen. Right, Solana keygen and grind. That's the command. So just for the sake of demonstration, with L it wouldn't work, but if we want to use it with pay, it looks through several wallets and then gives us the key pair. So right now it found very, very simply, it only has to use, okay, with 11 threads, it was like under a second. It found a key pair that we can use for our personal use. And there will be a JSON file written down here. So if I would give you the private key, you can also use it for your key. Now, how would it look like for the case of myself? When I wanted it to have Mike as prefix, you can see there is like 1 million searches that have been done, 2, 3 million, 4 million. So iteratively, the more keys you have, it's like an exponential amount of computation has to go through that. So also just like having 4 characters as prefix is very hard for the machine. And I will kill this process because it might take too long. And it probably takes like lots of my 11 threads, maybe even all of my cores for the calculation of this. So if you like one yourself, you can test it around. I can maybe show the code and post it here in YouTube. So also people online can access it easily. There is. And you can play around. You don't have to have pay as prefix. It can be personalized. And then the same workflow would be again, search for your directory. So Solana config get. Look where your directory is. There is the id.json. Just copy this part, paste it into your current file, and then you would replace your wallet. this is how you can personalize your own wallets. This is what I have done. I think it's nice to have like a structure. Obviously, it's not necessary. It won't affect anything in your code whatsoever. It's just a nice, fun way that you can do in Solana that you cannot. Well, there are some ways in Ethereum, but if you, let's say, deploy your contract on Solana, you would give a predefined contract, and in Ethereum, you would first deploy it and then get the address back. So these are some changes to Solana. All right, is there anything else? Maybe some general questions. All right, maybe some questions from the online audience. You can still ask me something. But yeah, let's maybe recap what we have learned today. So we have installed all the dependencies needed for successful Solana deployments. So we have Rust, we have the Solana CLI, we have Anchor, we have AVM, which is the Anchor version manager. We have Cargo, which is used for Anchor. After this, we have been going through the scaffold that Solana provides us, which is currently very rich. Last year it was like very low level, like restricted. Currently we have so many things that we can do. Like we have an entire front end already ready for us to just use. As we see here, like it was not possible before, or like not provided that easily as it is right now. So we have created it, put it, first interacted with it, created our own smart contracts, could be able to deploy it, interact with it, and have an online working version that people can use, which in my case is Superteam 101 Versal.app. Yeah, thank you for your attention. I hope you learned something. And this is how fast you can create your own startup. Basically, I've done it in a couple of hours. If you have done it several times, you can launch it very quickly. If you have all the dependencies left, let's say you could wrap it up in 30 minutes, have a working product that you can submit to any hackathon. Just maybe use some changes, you know, work around it, but it's like very amazing what you can do in such a quick time if you like to submit your idea to a hackathon. And if you're only into vibe coding, then you saw what I've done. I didn't code much today, like basically nothing. And if you have something like Cursor, which is also very powerful, you can use that, tell the AI what you like to change. And in the most cases, it works. I've used it myself. So you can test around, mess around with it, create whole startups even with only AI. If you are not getting too sophisticated, too hard of a workflow within the Solana framework. So yeah, let's see if we have any questions. Doesn't seem like it. So yeah, thank you for your attention. I think we will now, let me see through the agenda what's left today. Let me close this one. All right, so the next steps afterwards would be the Metaplex 101, where you will learn about what NFTs are, and afterwards Björn would show you how to use alerts. But I think we would need a couple of minutes, so we will make a break at this point and then we will continue. Oh, and if you have any questions, you can message me always on Telegram. So it's @MikePavel. Let me put it up here. So just message me if you have questions to the framework or anything else surrounding the scaffold, and I am happy to help you.
All right, everyone. Björn is setting up now, and we will continue in like 5 minutes.
Jetzt? Test, Test. Hört man mich? Come on. Ja, why not?
Can I have your attention, please? Next workshop is starting. Björn is going to introduce you into alerts by dialect things. Can you please give them attention? Thank you. Give you my life, Björn.
Oh, that's a great start. All right, let's get started. Hi, everyone. I hope you have heard a lot already, learned some amazing Web3 stuff. Today, I'm gonna show you something about our product stack that we are developing at Dialect. Before I start, maybe 2 words about myself. My name is Bjorn. I do developer relations for Dialect. So if during this hackathon you feel that you want to do something with alerts, or maybe even use our other product called Blinks, I'm your guy. So just hit me, shoot me a message, can be on Telegram, can be on X. I'm always at bjorn.sol, and this is how you can reach me. Otherwise, we are Dialect. We also have a Discord. It's discord.gg/saydialect. We have a dev channel there, so just join this one if you have questions, and then we are good to go. But before I start with my presentation, I have a small question about you. You might already heard about something about startups and all the great stuff, or maybe you will learn tomorrow a bit more. But this is a very important abbreviation that's here on the slide. And I'm not sure who of you has seen this before, who of you knows what it means.
I can give you the German translation.
So it's MAU, it stands for monthly active user. And this is gonna be a very, very important key indicator if you in some moment, maybe in some month, and I wish you all the best for this, go out there and try to do some fundraising. Because investors want to know if you actually build something that people want, and if you have good numbers there, they are very, very likely to give you some funding. And this is exactly what we are focusing on Dialect. At Dialect, we built an engagement stack for Web3. Maybe you know already how this whole stuff works in Web 2. You can send emails to users, you can send notifications to users, but on Web 3, the challenge is that users don't really come with their email address. Users come with the wallet, and this is super cryptic, and you cannot really do a lot of it. And this is what we saw at Dialect, and this is what we are working on. So we have 2 products in place. Our first product is called Blinks, which allows you as, let's say, a builder, bring an experience right to your user. So imagine these days, normally you see something, and then if you like it, you click on it, it forwards you on another website, and then you have to do tons of different things until you are done on this website. With the Blink, what we achieved is that we can basically bring this experience and teleport it right into, let's say, your Twitter account or on your website, on another website, so that it's super, super easy. It can be integrated into wallets. So it's many, many functionalities that you can integrate really fast with the Blink. I don't even have a screenshot of this here today because I have talked so much about Blinks, and if you want to learn more about it, we did a workshop 2 weeks ago, I guess, and it's all on the Super Team Germany account. So please check this one out if you're interested in Blinks, or come later back to me and we can talk until tomorrow about this topic. But today, I really want to shine the light on a second product that we have, and I've never spoke about this here so far, and this is our alert stack. So imagine this monthly active user. This is very important, but how do you get it? Because the user normally, he signs up, he forgets about you. But the cool thing is, what if you could maybe have something to tell your user, hey, why don't you come back into my app? Maybe because you do some nice DeFi stuff and you're about to get liquidated and you want to know about it, so you can add some more money into the protocol and keep your money. Or maybe because you want your user to come back and do something cool, like mint the newest NFT collection that you just brought out or something like that. And to do this, we thought, like, what can you do? Because again, the challenge is your users, they do not come with their email address. Your users, they come with their wallet. So there's this wallet adapter, you sign in, and then you are there. But basically, you cannot do much with it. And we built a product which we call the alert stack, which helps you solve this problem. And what you can see already, it's not just the users who love it. It's also many, many products in Web3. They are already trusting us with this. You can see here Drift, you see Meteora, you see Camino. For example, Camino liquidation alerts are there. Marinate sensor stuff, Tensor is there. Sorry? I have my slides not?
Not shared in the stream.
Oh, I'm so sorry. 1 second. Share screen. One second, please. Let's try again. Okay. It's all good. Now it should work, right? Carlo? Yeah? Okay, cool. So let's hope I find my presentation again. We're so back. All right, where was I? The top teams are building with us already, and those teams that are building with it even love it. Why? Because the way we designed it is that we have a super, super fast integration. I will show you in a live coding example how fast it actually can be to implement it, and it normally takes about 10 minutes and not more. So it's really easy, not a lot to understand, but a lot to gain here. And as I said before, this stack itself, it's called the alert stack. And the alert stack is a really, really cool way to engage with your Web3 audience. Because imagine, you have all those things happening on Web3. Everything happens on chain, but you never have any clue what's going on. You get liquidated, you have no clue. Next time you log in and you see, oh shit, my money is gone. You want to do a nice trade and you have set some trigger, but not really a buy order, more like, okay, give me a heads up once this event happens. Well, how do you make it? How do you get informed about this? Well, with our alert stack, you can do it. So this is our nice little notification bell that you see here in the middle, and this is where all these messages come together. And the cool thing, besides of having this stack, is not just that on the left side, what you can see, it's fully customizable. No, it's also multi-channel. So imagine, how does Web3 work these days? Well, we have our wallets. So you might want to have a notification in your wallet. Tick in the box, look at this, we have it. But then also, we have a Telegram bot. So, you know, we are on Web3, everyone is on Telegram. So we can send you a notification on Telegram when such a thing happens. And also, on top of that, we have email. So if you're very, very old school, you might not like Telegram, you still can go with email. So it's really a very, very nice way to get the notification that you need in the right moment. This is how they look like. On the left side, what you see is our Telegram bot. In the middle, what you see is our React UI. This is what we're going to implement today. And then on the right side, what you can see is email. In the future, spoiler alert, there's also going to be web SDKs for push notifications. But this will take a few more, maybe weeks until we finally release it. But I was allowed to talk about it, and I'm super excited about it. So I kind of am happy to spoil it. And of course, because you do have notifications, not every notification is the same. You might be a DeFi protocol. You have different needs, like, let's say, drip, because you want to inform people differently. And this is why we support so-called threads. So you can say, okay, I have a thread, and then my user, I will show you in the next slides as well, can just decide what kind of thread they want to subscribe, and then they will get all those notification messages. So as you see here, I think this is from Drift. So they have a take profit here. They have a new market listing announcement, a liquidation warning. So all that stuff, it all comes together in this one little bell for you. It's really nice. It's really handy, and it's also super fast to integrate. Another example, for example, here is Drip, as you can see on the left side as well, different kinds of alerts, and you can decide which alerts are interesting for you or not. Important is that you can choose. So it's really nice for you also as a user. Who is also a very powerful user of this? Well, it's our most beloved NFT marketplace called Tensor. Here on the right side, you can see our settings screen. So it's really just you toggle in what kind of subscription or thread or channel you want to have. Everything that's green, it's going to be sending you a message about it. If you deactivate it, obviously, you will not get bothered anymore. Tensor has already 20 notifications implemented, and since I started at Dialect, it's super, super cool to see how the teams think of those things, how they come with their big list of notifications, what they want to implement, what they think it's interesting for the users. And it's super cool also to see how they use this stuff to get more retention into their service, into their dApps. A message itself is a super, super simple way. It mostly works, it's basically a TypeScript code. So what you see here on the left side, it's really just message.send. You give it the type, the title, the body. You can give it also an action and an action URL, which means if you look at our screen right here, you always see this button here, right? Trade now, deposit collateral. These kind of informations are the call to actions, and you really just set it into this, let's say, in this object, and then you say .send, and it's going to send out. It's from your backend, and then our infrastructure basically does everything. So what means does everything? Well, a user, let's say Alice has subscribed to getting notified once there is a new drop, and it wants it to the web app. Easy. So our backend knows how to channel this message. Another person wants to have the tip out bit via Telegram. No, now it's deactivated, stupid, but let's say per email. So it's super easy. It just decided our backend sees who subscribed to those topics, and we just deliver it. It's done for you. It's really not a biggie. And as I said, we have bots for this on Telegram, so it's super easy for you to send notifications via Telegram. Also, what was very important for the team, so therefore I mentioned it already, this thing is highly customizable. So these are 4 different ways you can customize. But if you want to see how this thing can be customized, you can go, for example, to Tensor. You click on the notification bell. You see their nice let's say, pixel art thing. I don't know. I'm not an artist. Sorry, I don't know how this is called. But you see it looks way different, the box, than it looks here. And this is the cool thing. So it's our product, but the way you customize it makes it look like yours. It's like a super white label solution just to send easy and fast notifications to devs, and they don't even understand that this is a different product that they are using. And the way you can send stuff, the first thing that I showed you was a little code example where I just showed you before, like the infra with message.send. We also have a UI. So if you basically don't really think you're a good coder, once this thing here is implemented, you can just say, okay, I have my subscribers. I want to send a Telegram message. In this case, I would just click here, and I would 5,500 users would get my message. And all I have to do is I tell it the title, the description, the link, and basically what the link should say, the call to action, let's call it. And you say send to the channel, and it's done. It's super easy. And again, if you don't feel like programming, you still can log in on our web interface. It all works with the wallet. We will see this in a few minutes. And then you can also just use the interface to send a message, like super fast, especially important for marketing people because they normally don't know how to code. So it's very easy. We will see it in a few seconds. And the reason behind the stack is we really want you to help you with this boilerplate stuff. So if you integrate something, it can take you a lot of time in building all this tech. And if, let's say, this thing would not look like your app, it would feel like you would never integrate it. And therefore, we decided to, because our goal is to make it 10 times faster for you to integrate it, to fully customize it as well, so that you can really give the look and feel that you want your user to have from it. OK. I talked enough. Let's start with this little demo so that you can see how this all works. Let me open my browser real quick in a new window. And the first thing what we will do is we will register our app with our backend. The way this works is super straightforward. We go to dashboard.dialect.to. This is the domain. And on the left side, you see alerts. Let me, for 1 sec, please disconnect so that you see how it would look like if you are coming new to this. So again, we go to dashboard.dialect.to. And then here on the left side, you see the alerts tab. You click on it. And then on the right side, there is a guide. So you just click on the guide, and it gives you like 3 easy steps that you should do. We just follow them. So the first thing is we connect a wallet. I will create a new wallet for that. Let's call it create new account. Build station Berlin. Build station. OK. It's created. So new wallet is created. And then we just sign in with this new key pair. Say connect. So we can see now that we are signed in. Next thing, it asks us for a product name and a description. We call this thing build station Berlin demo. And then it also asks us for a picture. I just asked ChatGPT yesterday to do me a very easy picture for that. Let's wait until it's uploaded. OK. Say register. And that's basically it. So you see now here we are registered with the Build Station Berlin demo. The way it all works, again, is about your key pair. So this is my key that I just created. The moment I log in with it, this is basically my login and the way I can use it. So the next thing is we want to have this bell in our front end. So I saw today you already used the scaffold, so I will just follow this example. So let me very quickly open my terminal here. And then we say npx create Solana scaffold. This is correct. At latest. And then we call this thing build station. npx, sorry. Create Solana Dev. OK. So npx create Solana Dev. You already did it this morning, so I think you already have it. What we use is we use the Next.js template for this one. And because all we do is Next.js and JavaScript/TypeScript. I will just go with the no anchor version of it. Say enter. And then we have to wait until it's installed. Okay, I was thinking the internet would be a bit faster. Sorry about that. Okay, we're in there. Let's cd into build station. Build station. Okay. I have to do an npm install. I'm not sure. No, that's okay. Next step we do is we install the packages that we need. The first one is our Dialect Labs React UI. And the second package is Dialect Labs React SDK blockchain Solana. Chain Solana. Okay, let's open our editor and do a npm run dev. So npm run dev, it says we run on port 3000, so let's quickly open it. I have no idea why it thinks Safari is my new standard browser, I'm sorry. our dialect Solana SDK component with the app address. That's Dapp address, that's correct. And we give it a config. The config needs the environment in which we are. So an environment, and this is production. And then what we also have to do is close it here, and then we give it our notifications button. Yeah.
That address is the address from directive.
The Dapp address is your public key. So it's a good question. So let's talk about it. So when we did our first step, we signed in with our wallet here, and then we went to guide and we registered this app here. So because we registered this app with this key here, it now knows, okay, if you sign in with this key, it is related to this address. So it's basically mapping. And then what we do here is we tell our front end, because now we have here our scaffold, and our scaffold basically has no clue where this thing should point to, right? So what we now do is we tell our front end, look, this is the address, and we want it to listen to this pod, and then every time this address sends us something, I want you to send it. So it's basically the connection between what you see here, the scaffold, and the backend that we just registered. And it all goes over your public key. Notification button. Okay, good. So this is our component. And then all we have to do is we basically take this component now and we add it to the scaffold. So imagine here we have this wallet adapter, right? And now what we want to do is we want to have a little notification bell here on the left side to it. And the way to do it, we go to the app folder, we go to layout, and then you see in layout, you have this UI layout component, right? You click on it, and then you see this UI layout component has like the whole screen that you can see here. And at wallet button, you see here that they have the wallet button and the cluster UI select. So obviously we are talking about this section here. And then in this section, we also implement our notification bell. So to do so, let's first import it. Import dialect notification component, which is the thing that we wrote here. And now just, where was it here? Add it here. Dialect notification component. And if you go back to the site, you see now here is a little bell. And this React UI is really cool because if you click on it, you already see that there's a pop-up, everything is coming on. So it's really nice. So now one thing, imagine we do two things now. The first thing what we did is we registered our app with the admin key, let's call it like that. This one here, right? But now we are a normal user and we are on this website, so we cannot use the same key anymore. It wouldn't make sense, right? Because, yeah, I'm a different person. So to log in here, I'm now using another wallet. And I just use my hot wallet. So what you can see here, let's say TRZT at the end, it's definitely not 7GQU. So it's a different wallet, okay? We can agree on that. And now it's basically already done from the code part. All we have to do now is we have to sign up for messages. To do that, let me for 1 second reload the page. You click on the notification bell. It says set up notifications. You click on it. And then here you see the enable button. And all you have to do is to say enable. And you turn the notifications on like so. And this is basically all you have to do. If you want to sign up for Telegram, obviously, you just say your username in Telegram, and then you will get a prompt from the bot. Same goes with email. So now let's test it. I told you, I promised you, it's not going to be something that your marketing department has to be afraid of. So there is an easy to use UI. So let's go back into our admin panel here, and let's go to Compose. If I click on Compose, you see I already have one subscriber. This was me before. Now we say GM from Build Station. And let's just say we have a title, GM from Build Station, and then this demo worked. I say send to all components. It says sending alerts. Alert sent successfully. Let's go back. You see now here is a little green dot. If we click on it, it says GM from Build Station, this demo worked. So that's been it. Like 10 minutes, a few lines of code, that's all that you have to do. And out of the sudden, you can send push notifications to a wallet without having any clue who your user is, what their email address is, Telegram, no user management, nothing. It's just all there. OK, that's been it. Let me show you one more little thing. We have also, because sometimes you want to do a bit more cool stuff here. We have, for example, a dark mode. This comes already. We say theme, say dark. And now if we go back, you see it's all dark now. So a dark mode comes out of the box for it. Also the styling. If you now feel like you want to do more in terms of styling, you can go to docs.dialect.to, which is our documentation website. And then here you can see we have an alerts tab. The alerts tab has a quick start guide. But what I wanted to show you here is if you go to alerts and monitoring and you go to advanced React notifications, you have a whole styling SDK here. So styling your widget, right? Here are all the CSS variables that you can set to really make sure that you can style it the way you want. We have examples that really tells you how every line, how every icon is called. And then you really know how you can replace it, how you can change the stuff. Like it can just look like the way you want it. It's totally, yeah. I mean, it's very obvious, so I will just stop talking here. And our writing icons and all those things. So you can see it here. It's all there. So just, have some fun with it, play around. And if you run into any issues, shoot me a message. I can help. That's been it with our message. Two little things that I wanted to show you still. I'm allowed to spoil it. I said before we have blinks. And blinks is basically a way how you can bring an experience to another user. Do you guys know what blinks are? Do you know it? OK, perfect. Yeah, good, super. So blinks is a button. And once you click the button, it does the transaction on chain, which is pretty cool. So you don't have to go to a website and do all that stuff there. No, this button comes with this transaction to you. But how cool would it be if you get this liquidation information or this let's say, information that you're about to be, that there is a new NFT mint or so, and you can just do it right into this message. And this is what we are bringing very, very soon. So you are about the first people who hear about this. It's going to be alerts, blinks right into alerts. So now, when you, for example, see that there is a new drop alert, you can say thank to the creator, for example, or you can subscribe, or if there is this NFT that you want, you can bid or mint, or you can deposit into a protocol if you would do some USDC lending or stuff. It's now all right into this alert stack. Super, super powerful. Your user have to do nothing at all. They click on the notification bell, and they already have to click to finish the transaction that you want them to do. Also, what we just did was we sent an alert to a user, and it was very manual. But on-chain, many, many things happen. A liquidation alert is not something that you just send to a user manually. A liquidation alert happens because something on-chain happens. So because you cannot understand from every user every position, of course you need some sort of monitoring system so that you automatically can send out those alerts. And this is basically step 2. So we have a monitoring SDK, and with this SDK you can really see how your user has some sort of positions and then dynamically send messages from your backend right to the user. This is, for example, I think it's from Meteora, a position out of range warning, for example. So it's really, really powerful. You see here, Realms uses it to track new proposals. Yeah, Meteora tracks it for DLMM positions. So very, very powerful, especially if you feel, okay, there is the need for automation for that. It's all covered. It's all there. And that's been it for me for today. We are at Say Dialect on Twitter, Say Dialect on Discord. So if you have any questions, reach out. I am bjorn.sol. So also, again, feel free to follow. Feel free to send messages via Telegram or Twitter. And yeah, I wish you tons of fun with experimenting. I wish you an amazing project for the hackathon, many, many wins, and all the best. Thank you so much. Sure.
Ist noch an? Ist noch an? Okay, we will have another 5 minutes break and then we will go into NFTs with Metaplex and Leo's gonna introduce you there. So yeah, just give it 5 minutes and then we're back in the stream.
You see here, this is from the, it's hard to say, but if you
where you really have to pay attention and go through it with you. And afterwards, we are having food, networking, and mentoring if you need.
Test. Okay, guys. Well, I know it might be tiring. Yesterday I talked a lot. Today I'm gonna try to be briefly, but I will pretty much today we're gonna talk about everything the Metaplex has to offer. And we're gonna go a little bit more in depth into the code of like how you can create your first NFT using Metaplex Core. So, for who's not familiar with the NFTs and in general fungible token as well, pretty much if you ever interacted with any fungible token or non-fungible token on Solana, it was probably done via Metaplex. So we have pretty much 85% market share of all the fungible token minted on Solana. They're minted through token metadata. And at the same time, we're one of the only standard that it's only for NFTs. And we do that through Core, and we're going to talk about it today. So yeah, what is Metaplex? Metaplex pretty much it's three different things. It's a foundation, it's a compilation of programs and tools, and it's a DAO. So pretty much all the programs that Metaplex put out, and we have like programs like Token Metadata, Bubblegum, we have Core, we have the Candy Machines. All of these we're going to talk about a little bit about later, and all the tools pretty much are all maintained by the Solana Foundation. That is by the Metaplex Foundation. Lapsus. Sorry about that. By the Metaplex Foundation. And the Metaplex Foundation is a non-profit organization that supports the development, the security, and the centralization of the Metaplex protocol. But we have a DAO as well. So we have a token that is the MPLX token, and pretty much that guarantees you governance inside of the Metaplex DAO. And pretty much through the Metaplex DAO, we sponsor grants, we sponsor initiatives, and pretty much if you have a feature, for example, David here was one of the, he helped build out the MIP7, that is the Metaplex Improvement Proposal 7, that pretty much, and pretty much he asked, it was one of the people that wanted for the marketplace a way to actually list their 101 in multiple places. And so pretty much David and a group of people decided that that feature needed to be done. They submitted a proposal, the proposal passed, and now it's on mainnet. So this is the power of the DAO. So some number at scale, this is actually not very updated because actually since the last time I did this presentation, we actually grew massively. So we have almost 880 million digital assets created. We are more than 900 million transactions up to date for a transaction that uses our protocol, and we have 1.7 billion created. We created 1.7 billion revenue for the creator that uses NFTs, fungible token, and all our programs. And this has been across different verticals. We have real-world assets, we have meme coin, we have gaming, we have the pin, we have art, and probably if you are in the Solana ecosystem, you might know some of these names that uses our tech stack to power their solution. So we have Magic Eden, Tensor, Photo Finish, Ilium Mobile, Star Atlas, Pump.fun. So what can you do with Metaplex? As I said before, Metaplex is not only for NFTs, but it actually powers different standards. So we have the oldest standard that we created was token metadata. Token metadata pretty much is a way to give the possibility to token. They usually, probably you guys have talked about it in the previous workshop, but each token is just represented by a mint address. And mint addresses are not that readable. Like, how do I know what token is Bonk? How do I know what token is USDC and whatever else? So token metadata pretty much attached something to make the token recognizable. So you can, for example, add a name, you can add the image, and pretty much this is what you can see in your wallet. The image that you see in your wallet, the name of the token. Most of them uses token metadata to create that stuff. Naturally, it's not only that, because token metadata was the first standard for NFT as well. So you could use token metadata both for fungible token and non-fungible token. And the main difference with that is that the metadata account, that is an additional account that gets created when you use token metadata, is reserved for both fungible token and non-fungible token. But the way you can actually create non-fungible token is through the edition. What the edition does, it doesn't save much data inside of it, but what it does, it makes sure that the supply of the token is 1, the mint authority is revoked or is given to the Metaplex program, and and it's not divisible, so with decimal equal to 0. Because these are all the things that makes an NFT an NFT. Then we have Bubblegum. Bubblegum pretty much is the suite of programs that power compressed NFT on Solana. Compressed NFTs make it possible to scale the creation of NFTs to a new order of magnitude by rethinking the way we store data on chain. So the main difference there is that instead of storing the whole NFT data fully on chain, this data gets stored off chain and it gets computed into a Merkle tree that gets saved on chain. So pretty much you can have you can have a Merkle tree that is very, very big, and you can access and make sure that the data in that tree is correct by just recomputing the off-chain Merkle tree and saving the root on chain. So with 32 bytes, pretty much you can save 1,000 of NFTs. For example, we did some benchmark, and 1 million NFTs costed around, I think, $3. So it's pretty cheap if you want to do something consumer related. If you want to mint something at scale, probably compressed NFT is the best way to do so. And this is because, why Photo Finish, Trip, Ilium, Star Atlas, they all use Bubblegum for their products. Then we have the hybrid. Hybrid is pretty much you might remember that a while ago there was a craze of hybrid token. So pretty much it's a native program from a native Metaplex program that makes it possible to create NFT that are linked with a certain amount of tokens. So pretty much it creates double escrow that makes it super easy to give a certain amount of token and get back an NFT, and at the same time give back that NFT to get back a certain number of tokens. Other than that, naturally, there is a very fun stuff. So it enables re-rolling as well. So for example, if you want a railroad freight, you don't need to swap it back to token and then swap it back to NFTs, but you can pay a small fee in token and just re-roll the asset for you to try to catch the river asset. And Metaplex Core. Metaplex Core is our latest digital standard, and it's, for the first time, it's a standard that it's only made for NFTs. So first of all, it's very cool because as you guys see before, to create an NFTs, we needed 4 different accounts. We needed the mint, we needed the token account, we needed the metadata, and we needed the master edition. Now, Core is the new standard that needs only a single account to actually work. So the main difference before this and why we actually need a new standard was that 3 years ago, now probably 4, the first NFT has been minted, and you can see that it's like this little dragon, this creature. This was the first mint that Solana saw. Some people said that it's DJ Ape Academy, some people say that it's Solana Monkey Business. Those are maybe some of the major NFT, but the first NFT ever minted was this little creature. And the reality is, like, in these 4 years, there were never an optimization on how NFTs are created. So all of them were built on SPL token program. The token program naturally works really well for fungible token, but it's actually an overhead for a non-fungible token, and we'll see later why. It required multiple accounts, and it was very bulky and expensive. So with programmable NFTs, there was an evolution of token metadata that was needed to actually enforce royalties. A transfer actually had 8 different accounts. And so the problem there was that if you wanted to transfer multiple assets, it was very bulky, very expensive. So That's why we decided to go with core. So core as a single account structure, because as I said before, the SPL token program works really, really well with fungible token, but it doesn't work really, really well with NFTs, because there are so many fields in the mint, in the token, in the metadata that actually are not needed. So for example, we can see in the mint, we have pretty much anything that is in the mint account, we don't need it. We don't need a mint authority. The supply is always 1 and needs to be minted. We don't need the supply. Supply is always 1. We don't need the decimal. Decimals is always 0. We don't need the programmability of like all these different fields that are needed for fungible token. So the reality is that we pretty much, now you can create an asset with just 75 bytes that is pretty much 1/10, 1/15 of the cost of just this 4 account. So you can see that in the asset v1 account, we have the owner, we have the update authority, we have the name, and we have the URI. These are the only bare-bone things that an NFT needs. And this makes it super, super easy even for transfer. So before, the minimal viable transfer was having 2 token accounts and a mint, and you could transfer this mint through a token account to another. The problem with that is that the people that transferred the token, transferred the asset out, needed to pay for the creation of the token account of the person that received that NFT. So this was the first problem. With core, it's actually super, super easy. You just change 32 bytes in the owner field, and you can say that the new owner has ownership of that NFT. So we don't have any token account. We don't have any overhead costs. Once you mint an NFT, there are no other associated costs for transfer and for everything else. So what about collection? If we go back to the asset v1, we can see there is no space for collection. So with the idea of making the most programmable NFT standard and make it so bare bone, they came up with a for me, very, very smart idea in the design of like how the asset v1 work. So pretty much the update authority of the asset v1, it's not just the update authority that can update the value of the NFTs. It actually doubles up as a collection. And this works really, really well because if you think about it, really, all the assets that are contained into a single collection probably want to be updated by the same person. We don't need different authority to update different assets in the same collection. So pretty much we can set the update authority as collection or as an address. And what the collection does, the update authority over that asset is the update authority of the collection. This makes it super, super cheap because now we just saved 32 bytes. That was pretty much almost 1/4 of a cost by just doing this simple implementation. So what about functionalities? Before I said that core is the most programmable standard. And this is thankfully thanks to the plugin system. So the plugin system, it's pretty much a way to create assets that almost have superpowers. So if you remember before, to create a staking program, to create all this different stuff, was very, very hard because you actually needed to pretty much build from scratch lots of the functionality. So everybody had their own program, everybody had their own thing. It was very, very hard for people they might be not very, very technical dev, to actually come up with these smart contract and these functionalities. And most of the time, these functionalities could have had some bugs that could have led to exploit and everything else. So pretty much we decided to embed most of the functionalities on NFTs directly on the asset itself, making it super, super easy for everybody to create some very programmable feature handled by our program. No need to code, just implementing, just telling the program what plugin you want to add, and with certain parameters, and everything else will be handled by the program. So there are 3 different type of plugins. So we have the owner manage, authority manage, and permanent plugin. So the main difference with that is that we have, for example, owner manage plugin. These are plugins that can be added to the asset by the current owner. So we have, for example, the freeze delegate. So the possibility of giving the freeze authority over your asset to somebody else. The authority cannot do that. Only the owner of the NFT at that point. Then we have authority managed asset. So here, for example, there are different authority. The update authority, if it's in a collection, the update authority of the collection. If it's not a collection, the update authority of the asset. And the update authority of the asset pretty much can, it's the only one that can add this plugin. So or they can add or they can change it. And so, for example, we have the attributes plugin. For the first time in history, we have on-chain attributes. I don't know, for me, it's something that enables so many use cases, because before, all the metadata and all the attributes of an NFT were stored off-chain. And so it was pretty much impossible for a smart contract to enforce certain action based on the trades. Now, it's possible to save all these attributes on-chain, and by making this, you can actually enforce behavior based on the rarity of a trade or whatever you want. Lastly, we have permanent plugin. So if you played along with the Token 2022 program, the permanent plugin works really, really similar to that stuff. So for example, you can have a permanent transfer, you can have a permanent freeze, you can have a permanent burn. And the way that works is that pretty much no matter who's the owner, no matter who is the authority, no matter whatever the asset is, those authority can always execute those actions. And these actions are very, very secluded. So it's not a permanent authority that can do transfer, burn, and, and freeze. But these are 3 different plugins. So for example, if we want to make soul-bounded asset, and this is something that we're going to see later, we're going to use the permanent freeze delegate, and we're going to set it to none. So the asset is frozen. Nobody can actually update it. And it will be forever frozen inside of our wallet. Other than that, we have some external plugins. So we just talked about all these plugins that are inside of the asset. And then there are some plugins that can be added onto the asset. So for example, we have the app data plugin. So the app data plugin gives you the possibility of pretty much saving whatever bytes you want inside of the asset, but by giving that authority to another person, to an external person. So for the first time, not only the update authority can change stuff inside of the NFTs, but an external authority that we design can change this small piece of the NFT. This is actually enables so many use cases. I think I included it in the example, so probably we're going to see it later. But for example, a ticketing application. Imagine this. You're a ticket master. You're issuing all these tickets. You have naturally, you can save all the attributes. So for example, where you have a ticket, where are you seated, where are you, whatever. These are saved on chain from the attribute. But naturally, Ticketmaster doesn't have the possibility of scanning and say, and validating this ticket, because this is usually given to the venue. It's the venue that's validating the ticket. So the enablement of the app data is that now you can give the venue authority a way to say, yes, I scanned this ticket, or no, I haven't scanned this NFT yet. But at the same time, Ticketmaster can make sure that the venue authority cannot change anything about the on-chain attributes, making sure that everything is in order, the places, and so what you paid is going to stay the same. So yeah, just talked about the app data plugin, and yeah, you can go on our website, see all the plugins that we have. But naturally, if you have any plugin ideas, send them our way. We're gonna integrate it and make it public for everybody. Just talked about the ticketing. And yeah, if you guys want to learn more, you can scan this. It will take you to the, I think, to the core introduction page. Good. So let's jump. Oops. You got it? Nice. Good. I guess let's jump into the code. So, you guys see how easy it is to actually mint an NFT with Core. Okay, okay, is it big enough? Can you guys see, or should, yeah, let's make it a little bit bigger. Okay, now it's way better. Okay, so I didn't want to pretty much go from scratch. So there is a repo online where you can pretty much, it's called Metaplex Educational. So you can just like go through it, clone it down, and retry it home. So the way that it's structured, you have both example and templates. So for example, you can go through the templates, try it out yourself. And then if you can't figure it out, there is the example that pretty much has the code all done. So you can just like cross-check that and make sure that everything is done so you don't get stuck. So I guess the thing that I want to show you guys is just a mint asset and burning of an asset. So the way that we're going to do it, so first of all, for anybody that never used Metaplex, we actually have our own client to pretty much send transaction and doing everything, and that client is called Yumi. So you'll see that differently from what you guys learned today, we're not going to use create connection from Web3.js, but we're going to actually use create Yumi from the Yumi Metaplex bundle default. So yeah, pretty much works the same. So creating a Yumi works exactly like creating a connection from Web3.js. You pass in the what do you want to use. In this occasion, we're going to use DAppNet. And you can pass in the commitment as well. In this case, we're going to use finalize, it's fine. So I created a wallet beforehand that I'm going to use here. Naturally, you guys learned how to create wallet this morning. So you can just like create a new wallet, airdrop some Sol into that, and copy it here. I usually discourage people to just put the wallet.json inside of the repo, because if, for example, you forget to use the key d'ignore, you're just going to commit the full key and have all your funds stolen. So usually, a thing that I like to do is to get the absolute path from actually the config Solana folder that is pretty much where all the new keeper gets saved once you create a keeper using the CLI. So yeah, after that, we need to create signer identity, because the difference with Yumi is that it makes it super, super easy to pretty much partition who is the authority of the action and who's going to pay for it. Because, for example, it might be worth it for you guys to create a way for I'm gonna like gasless transaction. So, for example, the authority of minting a new token is going to be the owner of that NFT. But at the same time, I want to sponsor the transaction. So you can actually create a signer identity and a payer identity. And that makes it super, super easy to have gasless transaction on chain. So yeah, pretty much we're going to create a signer from the key, from the secret key that we imported from using a JSON parse from the wallet that we have here. And pretty much we're going to say, yeah, Yumi, please use the signer identity that we just created, and please use MPL core. Great. So this was the setup for every time you use Metaplex. This is pretty much the same setup for everything. So once you learn it the first time, it's very, very easy to copy and paste it. So yeah, we're going to start by creating the collection keeper. And after that, we're going to console log the collection address, because we're going to need it after when we actually burn the asset, because we're going to fetch both the asset and the collection, because we will need to pass them into the update transaction and burn transaction. So yeah, we console log the collection address, and I guess right now we are missing just the creation of the collection itself. So you can use create collection, and this is another tip for when you're using Yumi. The structure of everything Yumi related is always the same. So instruction, you open the parentheses, you pass in your Yumi instance, and then you open the squiggly parentheses, and pretty much pass in all the arguments that you can find inside of the inside of here. So in this occasion, it's the collection, and we don't need to specify who's the update authority and who's the payer, just because this will be handled by Yumi. The only time we need to actually set them is when they're different from the Yumi instance that we just created. After that, we need to create the name, and we have to add the name, we have to add the URI, we have to add the plugin, and yeah, and the external plugin adapter if we want. So yeah, I guess let's start with collection. Then we pass in the name. My collection is fine. MyCollection.com is fine as well. And this time around, we're gonna do the permanent freeze delegate as well. So usually, if you want to do a soul-bounded NFT, you need to make sure that it's a good thing to make sure that the freeze authority is actually set to none. So the authority cannot unfreeze the token, making it not soul-bounded. But since I want to showcase even the update feature and the burn feature, for this time around, I'm gonna still set the permanent freeze delegate authority. And actually, if we decided not to set, like I could do authority and set it to none, for example. I think I need to create a string. Yeah, it's plugin authority. So it's type address. We can say address. An address we can pass in, for example, our own thing, or we can set it to none, I guess. Yeah. And this will pretty much make it impossible for anybody to unfreeze the asset. This time around, we can omit it since I want the Yumi the Yumi signer instance to be the authority. After that, we created the collection. We do send and confirm, and easily we can just use create collection. Like here, we already sent and confirmed the transaction, and so we can gather the signature and pretty much deserialize as base 58. And the way that I set it up right here, it will show us on the Explorer the transaction. This is something that you guys can copy and just use it for whatever. Now we create the asset. So same as before, await, create, Yumi. We pass in the asset keeper that we created. In this occasion, we're going to pass in the collection as well. Then we pass in the name. That is going to be my asset, myasset.com, and we can pass in the plugin. So this time around, we're going to create an asset with the attribute plugin, so we can showcase that they are on chain as well. So attributes, and then we need to create the attribute list that is a vector of key and values. So key, workshop, value, Metaplex, workshop. Great. Then, as we did before, there is a typo. Oh, yeah. Thank you. Send and confirm Yumi. Same thing as before. We just like get the signature and deserialize it as base 58. Cool. Let's run it. Collection address created. Export. And yeah, asset address. And we'll see asset created, hopefully, if I didn't make any mistake. And asset created as well. Great. So we're going to copy these into the burn asset as well. So asset before. collection. Great. So yeah, this time around, we pretty much we just pasted in the public key of both the asset and the collection. What we're gonna do, we're gonna both fetch the asset and fetch the collection. So the way that works is that pretty much it takes all the data that is currently on chain and pretty much save it into this variable that you can actually console log to see everything that is going on the asset. So we're gonna do it here to showcase pretty much how that works. And this can be done, and this is done with the collection as well. And usually when we need to use the asset and the collection, this is how you need to, you cannot pass in just the public key. You need to pass in the pretty much all the data of a collection and all the data of the asset. So yeah, wait, update collection plugin. We want to make it, we want to unfreeze our NFT. So we do collection. This time around, we just need to pass in the public key. And then we need to pass in the plugin. So we can just, with update collection plugin, we can't update multiple plugins at once. We can just update one. So in this occasion, we're updating the permanent freeze delegate to be false. Same as before. Collection updated. And now finally we can burn. Now that we have frozen the asset, we can actually burn. So burn. Hear me. Want to burn the asset. And then we always need to pass in the collection as well if an asset has a collection, because for example, we could have a plugin, a collection plugin that makes sure that you cannot burn the asset. So if the asset has a collection, the collection account needs to be passed as well. Send and confirm Yumi, and we should be done. I think I'm fetching the example from the example, so just gonna copy them here. Yes, so bird asset. Yeah, as you can see, we can see everything about the asset itself. And the cool thing about it is, first of all, we can see that there's a collection. But the cool thing about it is that these assets already said that it has the permanent freeze delegate. So we can fetch the collection plugins by fetching the asset, only the asset. So it makes it super, super easy to interface with. So now we updated the collection, and we're gonna see that the asset gets burned. And yeah, it's done for the day. Asset burn, and it's done. Anybody has any question? Yes.
Could you technically create an NFT, send it to someone, and then somewhere in the code I would change, because I have the authority to send it from the person who sent it to anyone?
Yeah, if you retain the permanent transfer delegate, yes.
Can you somehow prove it? Like if I am the one who got the NFT sent, can I verify if somebody else can transfer it from my wallet?
Yes, like if you can control, like you can fetch it and see if like the permanent transfer plugin is there. But if like after the fact, yes, you can check it out because it's an on-chain transaction. So you go through your wallet and you see like, or like you go through the asset transaction and you see when that happened. Anybody has another question? If not, we're done. Thank you.
All right, cool, friends. With that, I think we're pretty much at the end of the content part from today. As I said, Anchor, unfortunately, we have to take it up another session because, yeah, the mentor unfortunately missed the flight. But yeah, tomorrow we're also gonna have some more workshops. So tomorrow we're gonna go more in like from builder to founder. So from like all the takeaways you took now, like technical takeaways, to take them and go a bit more into like product and yeah, how to start actually being a founder. And we have like a matchmaking session here for people in Berlin, basically, where you can try to find co-founders and do some speed dating. And yeah, with that, I think our online part is done for today. And yeah, have a great evening and see you tomorrow.